work on Leetcode 0192, the minimum operations to make binary array elements equal to 1. And this is a very similar problem to the previous one, to the first version of this problem, 3191. However, it is said we can do the flips starting from I to the end of the array. So it's not 3 anymore. So this means if we flip an element from index I to the end of the array, and if we actually flip all of them, then what will happen? Because the nth length is 10 to the 5th, we will have a violate the time limit constraint. So what shall we do? The way to do it is like this. We can observe one key observation. Observation is the sequence of flip does not matter. This is a very key observation, so it can help us to design the algorithm for all of these problem, including the 3191 actually. So if we already know the sequence of flip does not matter, we can sort all the required flips from left to right, and we can loop from left to right, and whenever we require a flip, we will flip it, and we will remember how many flips we will do after this. Okay, so we have f equals 0, and we can loop from the first position all the way to the end position. And if nums I equals 0, nums I equals 0, after flip, nums I is 0. So this f is how many flips on current position. Okay, so it plus f. If this number if this number is even, what does this mean? It means this position is 0. Okay, then what we will do is we will need to flip it. So nums I equals 1. You actually don't need to, no need, but we will just write it here. Then f plus plus, which means we will do a flip here, and all the following flips will have increased by 1. Then because we can flip any elements, which means we can, no matter what we do, we can flip all the numbers to 1, right? And we just return f. Yeah, I think it works. Let's submit. Okay, so the key observation is the sequence of flip does not matter. Then we just remember how many flips on the current position, and it will propagate to the end. And then we don't need to actually flip the current, but we just virtually remember the flip. So we plus plus to f. Then finally, how many f is how many times the flips. Okay, and I think that's it for this problem. Thank you, and see you next time.